I went live because I wanted to record this weird thing that's happening. I've actually been kind of stuck really at the moment with some issues, and then I went and checked, and I actually got some of the laminations on one of these arrays upside down. It was inverted. I've got an entry side and an exit side. Well, this is the hole that holds the lamination. It's hard to see with that actually. Let's just get one of these. But the laminations are basically arranged in a certain way. Oh, that's not going to help either really. Let's see if I can try. I'll use my fingers to. So laminations are pointing at an angle as the magnet rotors come round at a certain point. Well, on the laminations, they're actually tilted the other way on the exit point. Well, I got two magnets. One was facing forwards, one was facing backwards, so they were alternated. And that's why this particular coil set here wasn't working properly, because the flux lines are actually channeled through these steel laminations and focused in such a way. It's a bit like a flux gate or something like that. So anyway, I thought, well, while I'm at it, I'm going to flip these 4 coils, the 2 that are down here, and these 2 coils. I'm going to flip them the other way, so that the ones on this side, the 2 coil sets, that's 4 coils on this side, the laminations are facing into the flux as the rotor's turning, and counterclockwise. Well, it's clockwise from your perspective actually, from the camera's angle, so clockwise this way. So the laminations are facing in towards the flux as it's entering on this side, and they're actually facing away as it leaves on this side. And doing it like that is actually a very improvement actually. So what I'm thinking now is alternating my lamination so that the first coil set faces in, the second coil set faces out, then the third coil set faces in, and the fourth coil set faces out. So it's actually be better if I draw it. Let me just draw a little sketch so you can get a rough idea what I'm talking about. It's hard to explain it. Right. What I'm about to draw on, what is it? Oh, it's just a scrap bit. So my laminations, so I've drawn a little drawing. I don't think you can see that very well. Maybe you can see it. So basically, as the magnet rotor enters the first set of coil sets, the laminations are facing into the flux as it's entering, and these are facing out, and these are facing in, and these are facing out again. So that's what the next step is, to try that out. But yeah, I'm not going to do it right now because I've just changed these 4, and I want to observe what's going on. I mean, RPM has dropped a little bit though, because we aren't drawing much current, and I think my bearings have got given me some problems again, because we're at about 3,700 RPM at the moment, which is quite low really, but the current on the meter is about 60 milliamps. It's about Yeah, it's hard to see that. Anyway, I can't really show you right now, but so it's just fine about actually unplugging all these coils and then connecting them all back up again. And, yeah. So pushing out about 50 milliamps or so. It's not a lot, but I have noticed a bit more drag actually. I'm not sure if I've got some crossed off somewhere. Let's just try swapping these two coils around. Actually, let's try that. And plug that. Come out, you bugger. The output actually went up just then, which is kind of interesting. Speed is about the same. Oh, I was dropping in speed now. Yeah, that's actually worse. I'm basically swapping the phase around by swapping the polarity on the AC coils. It's speeding up now. Obviously current's gone down as well. Are we still going to speed up? It's about the same. We're actually low current though. I'm looking for speed up, you see. Yeah, it is going, it's speeding up now. 3749, 37, come on, 3750, 50 RPM right now. We're not going that fast. I suppose I ought to bring the RPM meter across a bit nearer if I can. I'm not going to see it there. Let's put it on the battery. Okay, so there's the RPM. Let's swap these two around. Output current is about 60 milliamps. It's a bit easy to do it with the pliers. current's actually low, it's about 40 milliamps. So it's gaining speed, so we'll see what happens, see what it settles out at. Actually no, speed's actually worse, so I'm going to put that down. Yeah, there's such a lot of things you can tweak with this to tune things up. Like I've also been testing with my choke, my other choke, connecting that. I need to get this soldering iron out of the way because I'm not using it now. I had to resolder the wires back on when I dismantled the coils, and you know, it's strange because I haven't got that situation where it's speeding up when I put the load on for quite a while since I changed a few things, and this is what happens. Sometimes you change things hoping it will be better and you make it worse. This is life, I'm afraid. Right, let's try with the crank my choke up to some of these stages. See what happens. Also, I've got sockets in the bottom of these toys that I made. They're hard to get to. See what happens. Lower. It's dropping, so that's worse. Now let's try the other one. Current's lower. Speed's picking up. No, that's not good. Current, about the same. Current's a bit higher. Let's see. Yeah, I'm helping. Yeah, I'm kind of in a bit of a hole again. Maybe my bearings are drying out again. I don't know what's happening with them. Well, that's not helping, so probably, I don't know. Ooh. Trying to get some more WD-40 in. Take the load off a minute, let it speed up. Take the speed up a bit. Let's pick it up a bit. I'm going back down again, so I don't want to go too high. Current limiting's on anyway. Alright, let's put the load back on. Right, yeah, there's definitely a problem. I've kind of got a problem somewhere. I'm not sure if my bearings are binding a bit, but there's definitely a rubbing sort of sound. Sometimes crap. It's these cheap bearings. They're just not very good. They're not very good quality. I'll have some trouble charging up my nickel metal hydride batteries. I've been trying to charge them up and they're not taking a charge. Probably had it. That's what my charger was just finishing again. It shouldn't be finished because it hasn't. It's been doing a cyclic charge, discharge cycling and charging, and yeah. I'll see if I can get my meter in the shot if I can. Not very easy to get it in the shot. You can't really see it anyway. It's the analog one. Doesn't show up very well. It's around 50 milliamp scale. It's about 60 milliamps. It's going off the scale right now. You can see it right across the scale right now. Turn it back to the 50 milliamp range. It's about 60 milliamps. Which is not really enough. I was getting a lot more previously. So there's no point in leaving it down here because you probably can't see it anyway. I could put my digital meter, but I keep running batteries down. That's why I was charging up my nickel metal hydride, because I was running my meter off that. And about could put so yeah, what I was thinking of doing is obviously I've got to get this fridge sorted out, which is next week. I'm going to get a new mini fridge just temporarily, something I've got. At least I'll have a fridge. And then I'll sort my big fridge out later. I might have to flush the system because I think I've got a blockage in it. So at least it's the ozone friendly gas. It's just butane gas which it uses, which is R600A. It's just standard butane type. Isobutane it's called. It's basically got no gas smell in it, so you can't smell it. And that's the only difference between isobutane, R600A and lighter fuel. Lighter fuel's got a scent they put in it so you can smell it. So yeah, I don't know why I'm waffling about that anyway, but yeah, I'm distracting and I'm sidetracking myself. I've been trying some different capacitor values, but these are 1 microfarad basically on the end of the circuit. They act as a buffer to charge the next stage when the triac switch is on. If I take them out, it doesn't work. If I take one of these out, take that stage out, they all go out because they're working a cascade. It'll actually speed up now to compensate for the fact that that one's missing. So yeah, it will work partially. Let's just take that one out. Yeah, there'll be a certain amount of energy that's passed through the system. Oh, actually, let's see what current we've got. That's interesting. Yeah, it's not too bad actually. I'll leave them out for now. You can plug and play, you see, with these things. Let's take another one out, see what happens. It's probably going to stop working now. Yeah. Yeah, absolutely no continuity through this. Oh, it's speeding up now. It's working again. Oh, fascinating. Oh, we've got some action even without the capacitors. Right, let's take that one out. Let's see. Oh, there we go. Oh, cool. I've taken all the capacitors out and it's working again. 60 milliamps. Actually, that might be better for that. I went to 50 milliamp range and put out on me. Oh yeah, that's pretty good actually. Consider I've taken all the capacitors out. You see that they're in a chain. So my inductors are the only thing storing the energy right now, which is kind of interesting. So they actually seem to be working better without the capacitors right now. That's fascinating. Let's tweak it without capacitors in it. This circuit does some weird and wonderful things sometimes. Not a lot of tuning though without the capacitors in. But we're actually pushing a bit more juice out. Try interrupting the circuit, you'll probably die now. Yeah. Absolutely zero output then. Let's just leave it off a minute. We've got switches here. See if it'll still work with this middle section interrupted. It just goes to prove one thing really. This thing is more of an inductive circuit. The capacitors are just there as an aid, but they do introduce a lot of drag on the system. Without the capacitors, just using the inductors, we get a much better effect. As you can see, we get more RPM. But I've interrupted this wave, so I'm going to put the switch back on. Right. When you interrupt it, they all go out, right? And it has to gain speed again to reinitialize the chain reaction, because it is a chain reaction. What's going on? The energy is being cycled through the whole circuit and being drawn on the output. And if there's no draw on the output, then this circuit doesn't work. So I've got these turned right up now. I went down to 50 milliamp range, it interrupted the cycle. Right, it's gone back on again now. There we go. So 50 milliamp range. Back to 500 milliamp range. Yeah, I'll probably need to put some smaller capacitors in here really. I'll tell you, I need to order some more non-polars that are smaller values, because these are a little bit, they're not exactly the right type of capacitors. These are metal film, they're not ideal. I want something that has a slower, actually ironically, something with a higher CFR, not a lower CFR, because the way this works, it needs a delay. It needs to have like a stop start, or I could put the capacitors in series with the resistor even, which might improve things. Oh shit, I've overloaded my input because I was on a higher speed and it's cut out, so hang on, I'll have to set the voltage again. Oh, let's drop back down to where it should be anyway. Yeah, I overloaded it. I was going too fast, I was pushing it too hard, but it's okay anyway. It's reset itself. Let's check the temperature on there. This color should be pretty cool. 34 Celsius. That's fine. Oh, it's reset again. I've overloaded my service capacitors. They've discharged too much. I'm going to have to turn this off and let it recharge at the other end over there across the room. Remember, the power supply that's running everything, it's only rated to about 600 milliamps or so. It can't, if you try to push too much out of it, That's why I blew my power transistor on previously, I think, because I was pushing it too hard. So we're basically ticking over at idle speed right now. Anyway, that's interesting. Yeah. It might be worthwhile trying some capacitors in series with a 10 ohm resistor or something on this circuit. I really need to build another board. I need to build a new board with 100 ohm trimmer pots so that I can tweak things a little bit more easily. I have got some 100 ohm trim pots. It's just going to be they're quite big. And there's not a great deal of room on this board. I should be able to sort some new design out at some point. I just need it more customizable. I need it to be more tunable and attainable. It's quite attainable, but you know, you can tune things quite a lot on it. But there's a lot of things on here I would like to be able to tune a lot more, which is the capacitance on the ends, which is in the circuit. I mean, this is one block of circuit really. This is just one stage. These two coils are basically one of these, because there's two windings on there. Those are my LEDs at the top, which is down here. It's actually upside down, really. These are my triacs on each half cycle, and the capacitor there is actually where I was connecting that choke in the socket in the middle. So you can put capacitors in there, but it's always been a problem with the capacitor. It actually causes more drag if anything. So the chokes make a better improvement, really. So I don't know if you can probably seen that previously anyway. So ignore the yellow lines. I mean the red and blue line that just came through from the other side. Yeah. My circuit capacitors are charged up again. Right. Triacs are about to fire in a minute. You can't really see it on this meter, but it's slowly climbing in the current. To get that on there without it blowing away. What range am I on? I'm on 50 milliamp range. Well, it's not firing yet, so I might just... That one's a bit too high maybe. There we go. But you can't see the LEDs firing. I like to hold this damn meter. Very tricky to get it set right. Because the whole cascade has to be triggered, not just one end. If one end's triggered, I get a lot of lag and not much output. Might have got them set too high actually. Really does need a little bit of capacitance in there. As you can see, the meter's banged over right now. My arm's not getting tired because I'm resting my elbow on my knee, so you know, this meter, I've had this meter since 1982. It's falling apart. The plastic's disintegrating on the lid and the back cover, but the electronic part still works great. It's just that it's disintegrating. It's so old. The actual handle broke on it, so I stuck it on with a cable tie. The cable tie is holding the back cover on as well. Actually, I could 3D print a new. I just keep forgetting now I've got the 3D printer. I could actually 3D print a new handle for this because this handle's broken. I might do that actually. I might design a new handle for it at some point. Well, it's not doing much right now. Probably need a bit more speed again. It did drop back to the default 25 volts, so that's probably why. Right, that's it. Right, at 27 volts. I'm only at 27 volts right now. Meter banged across. So what I want to do is I'll put this meter down because my arm's getting tired of holding it. I'll explain what I was thinking of doing, and that is I wanted to make a new board that's got a bunch of switches where I can switch or jumpers from my circuit. Have a bunch of jumpers on the board, so I could cascade my circuit so that the triacs are actually cascaded across individually to each subsequent section. I've got to work out a new diagram for this. I've got to work out a new schematic, but because I've noticed the phase differences between each coil. Obviously you've got the minus waveform and then you've got the plus waveform. I want to switch individual phases relative to the following stages so I can optimize the way it works really. So some of the phases are inverted, they're actually negative phases, but relative to the following phase, if I can synchronize some of the phases, I don't know, it's hard to figure it out, explain really, but yeah. I also want to be able to reverse, well not reverse polarize, but yeah, there's some other ideas I've got about the circuit. I mean the key is with the circuit, I mean how the circuit works, it's very important that I get that right, and I'm also planning on making some better chokes that'll work on here. I was either going to make some smaller chokes using a small transformer about that size, or I'm going to wind some bigger transformers and try those as well. I haven't decided exactly what the next step is, but I definitely had some success previously in that previous video when it was accelerating, so I'm not far away from where I need to be. It's just hitting that sweet spot, you know, it's a sweet spot you've got to get on really. Anyway, I think I need to put these capacitors back in, or maybe I can find something smaller. Hang on, I'm going to go and see if I can grab some smaller capacitors to put on there. You know, I've got some noise suppression capacitors in here. They're about 1 microfarad, but I believe that they have, these are 1 microfarad. I believe that these have a resistor in line. I've had these a long time. I'm just curious what these will do. They've been in storage for a long time and I just wondered if they were any good. The legs are on now, so I'm just going to try them. I think I need my pliers. They're a bit bulky. What these are like? I'm just trying over there and see. See if I can get the legs in. They look massive. Trying to get the legs in. Well, that's weird because they're not doing the damn thing. That's fascinating. Unless it's because I need them all in. See, I've got. Let me just check one of these on my meter anyway. I wonder if they're any good still, because they're pretty old. And they are noise suppression capacitors, they're for mains really. But they're saying that these things are for mains as well, so let's see what this measures. Yeah, it's definitely 1 microfarad. Yeah. I have to wiggle the legs in to see what's going otherwise. That's weird, these aren't doing anything yet. Why? Have I pulled some off? It's like I've got a connection loose somewhere. Oh, the things come out the meter. That's why. The lead on the meter would come out. So there's not a lot of room. Get in. Right, I've got those massive things in. And to adjust everything. What's cracking out? Oh, it's this thing. Well, current's not very good, it's only about 40 milliamps, which is ridiculous. I'm going to go in a bit because I'm going to make some food. I'm going to make some bacon sandwiches. These are a bit big anyway, because these are 1 microfarad. These little brown ones. I really need some about half the value as that. Let's see what are these things. These are 0.1 microfarad. Well, that's a big jump from, yeah. I'm going to have to look for some more intermediate really. Well, I might as well take them out, put the brown ones back in because they're the same value and there's no difference. Let's pick up speed first and might just leave them out actually, I don't know yet. Yeah, definitely leave them out. I have got more current without them in than I have with them in. So it goes to show you that capacitors for this circuit seems to be detrimental, unless of course I'm up near the top end, but the inductors seem to work better than the capacitors. It's doing cycling right now, it's going up and down. Yeah, it goes into the cycle where it latches and the circuit replenishes itself, then it overdrains itself and that no longer latches, then it starts to pick up speed again until it starts to latch again. It's complicated. It's the way these triacs are triggered by the presets and trimmers and everything. Yeah, I'm just going to leave the capacitors out. I'm going to find something smaller because these are a bit overkill, these big things. Yeah, I'm curious. I'm curious. What these are mobs, but they're rated for mains. So I'm just curious what effect these things will have. Obviously, we probably won't do a damn thing actually, but still curious. It might pick up tangents, that's about all. Nope, didn't do a damn thing, I thought it wouldn't. I saw them lying in my component box and I thought I'd try one. They're actually designed to suppress transients, as in spikes, but the rating on these is too high anyway, so I didn't expect them to do anything. But you never know, unless you try it, do you? I've got some 10Ns here, which I'm going to put some of these in. I actually got these for a voltage triple circuit. I only want a small amount of capacitance on there really. It's just to help with the trigger circuit. hopefully to reduce that cycling a little bit. Hopefully, I say. But they're probably too small, these 10 ends. I probably need something like oh, it seems to make a bit of a difference though. We'll see in a minute. Hang on, we'll just switch to 500 milliamp range. No, it's not opening much. No, I need something a lot bigger than that, something like 220 or 330 nanofarads, but I don't have any that big. Or, yeah, I'm going to have to order some for this. Let's just back this out a little bit so we can get rid of the cycling a little bit. So if you latch them on too hard, it does push out a lot of current, but what's the point if it's going to start cycling on like that? Too much vibration. I'm actually wondering about using some normally on type devices. I was actually originally looking for some normally on triacs, but I couldn't find any. I want some normally on, or maybe there's a way I can invert the input signal. Current is pitiful at the moment. Output current, that is pitiful. At least one thing I've learnt today that it works a lot better with the inductors rather than the capacitors, and my inductance needs to be greater. I need more millihenries, more storage in the inductors. That is the biggest drawback with the circuit right now. That's what's holding me back, because you can see that the RPM is good, even when we're drawing 50 milliamps or even 100 milliamps, but everything goes to shit, really, to put it bluntly, when you start adding too many capacitors, because they advance the circuit. The capacitors advance the circuit when I want to retard the circuit. The whole point of this is to delay, and the capacitors add advance to the circuit rather than retard. So they're basically triggering earlier because the capacitors, whereas I want the delay there, and you get what I'm saying. Because inductors have a high impedance on an initial pulse, and their impedance drops to a low impedance as they become saturated, which is the whole point of this circuit. Yeah. So what we'll leave this to come out. No, a little bit. They do make a bit of a difference. I'll leave them in for now. Turn the light out now, because I'm going in a minute. Anyway, we can watch the lights, can't we? Not much else to see, really. I suppose I can bring my other light across the room here in a minute. Won't be too bad. Won't be dark, then. One of the issues with the triax is that they're normally off and you trigger them on. I really want something that I can trigger off rather than on. So I need some sort of inverter circuit. Because the rise time is important, as in when the circuit enters. You see, what's happening is the triax are triggering on the peak, right? As you know, it's when the magnets are moving away from the coil on the generator down here. That's where the drag happens. You don't have drag, you don't have reluctance or drag on the system as the magnet is entering the coil. It happens mainly on the exit of the coil. So what I really want is a normally on situation where the actual triax are actually on, but trying to find the damn thing is a problem. You know, I've been trying to find those devices. You can find some MOSFETs that do that, but there's another way of doing it, and that is to create an inversion. It's to create a circuit that inverts everything, so that you actually remove the biasing from say a bunch of MOSFETs, because you'd have to use a bunch of SCRs or something to remove the biasing so that they actually turn off. And that's more complicated. It's very complicated to build that, really. It needs more components, everything. I'm wondering about looking on eBay again, actually. See. I could get a bunch of SCRs. I could get I hate eBay sometimes. You search for a semiconductor and you get something completely wrong. So I'm looking on eBay for something that would do the job really. Oh, sorry, it's messy. So the trouble of finding something like this is it's extremely let's see, no. Normally on and I don't find anything. The normally on thing completely screws up the search term. What the hell is this thing? It's contradictory. It says it's a voltage regulator and an SCR triac. What the hell is that thing? Can't even see the writing on it. Typical Chinese counterfeit probably. How the hell could it be all of that? How could it be a voltage regulator and an SCR triac and a cyroscope diode? What the hell are these people selling? I'm going to do a search on on the internet because this is useless. Oh, that needs to be in a phrase. If I just find the type that I need, I can they don't put enough information on eBay, that's the problem. Oh, this is a PDF, it's going to take a while to download. Maybe I'll just put that box over there. Go down there. Come on, download. Flipping the internet slow. Let's open with a different viewer. I need to download this really. Right, I'm just going to download, save it to my desktop. Pretty big is that file. That's what I'm looking for. A static induction thyristor. Well, I'd have to use two back to back because it's not an SDR. Yeah. see if I can find. Let's see if I can find it on eBay. I bet I can. Nothing much there. It's true they say that eBay sells a lot of junk, because they don't even sell, I don't think, well, unless I need to go by type number. Try another search. Well, that downloaded alright, good. I'll go and check that out in a bit. Well, it's definitely for motor control circuits, that's for sure. I need to find one though that will do the job that I'm looking for. What the hell? Was it being deleted? Shouldn't have been, that's strange. What? But it's downloaded. What the hell? Oh, it must be still downloading, I don't get it. Did this thing delete itself? Oh, it says failed. Failed to download. Flipping it. Oh, if I search for flipping it, got all these flipping Star Wars stuff now. Don't believe it. Garbage. Oh, go away, Star Wars. Flipping heck, I'm looking for static induction fires to not flipping site. This, whatever it is. I don't believe it. eBay. You are. This second. Waste of time. I give up on eBay right now. Let's try buying. Let's see, buy. Well, my internet's pathetic right now because I'm live streaming. I'm gonna end the stream anyway because yeah, you don't want to watch me search all this stuff. It's boring. Anyway, when I figure all this lot out and decide what I'm going to do, or I could use transistors actually if I use them back to back. Circuits which makes it more complicated. I just have to work it all out and decide what is the best have to take really, because a lot of this stuff is experimental anyway, so. Yeah, my generator is doing something interesting at the moment. The alpha voltage has got to about 8 volts. It's doing a bit of preemptive cycling. It's actually pulse charging at the moment. Anyway, yeah, I'm going to disappear.